Here are the top 10 things you need to know about sequences and series. Must know number 1. What is the definition of a sequence? Well, a sequence is an ordered list of numbers that follow a specific rule or pattern. So an example of a sequence of numbers would look like this: 3, 6, 9, 12, 15, and so on, where these 3 dots indicates that what we have here is an infinite sequence. The pattern goes on forever, and the 3 dots are called an ellipsis. And like we said in the definition, the order of these terms in the sequence is important, and each of these terms can actually be indexed based on what position it's in. And the notation we use to index each term based on its position looks like this, where the first term, 3, we would call that term 1 by writing a sub 1. That subscript 1 is just an index telling us that this term, 3, is the first term in our sequence. And then the second term in our sequence, 6, could be called term a sub 2, and so on. So to describe what we call the general term of any sequence, we use the notation a sub n, which just means the value of the nth term of the sequence. And because every sequence of numbers has a pattern or rule, we can actually write an equation that allows us to calculate the general term a sub n, of any sequence. So for example, for this sequence, 3, 6, 9, 12, 15, to find the value of term a sub n, the general term of this sequence, I would just have to do 3 multiplied by the term number, and that would give me the value of the nth term. So 3 times n gives me the value of a sub n. And to make that obvious, if I listed above the values of these terms in the sequence, what term numbers they were, we could easily see the relationship between what term number they are in the sequence, and n represents what term number they are, and then the actual value of the term, which is represented by a sub n. Notice the first term is 3, the second term is 6, and so on. If we just multiply any of the term numbers by 3, we get the actual value of the term in the sequence. Right? Let me show you how this formula works. For that formula for the general term, if I tried to evaluate the fourth term, it would say a sub 4 equals, and then just replace this n with 4. It would be equal to 3 times 4, which equals 12. And we can see that, yes, the fourth term is 12. And if I found the value of the fifth term, that would be equal to, well, just replace this n with 5. And that would be 3 times 5, which is 15. And once again, yes, the fifth term of the sequence is 15. So this formula could find the value of any term in the sequence, just replace the n with what term number we want the value of. And now let me make a bit of room so we can try one more example. This example states to find the value of the first 3 terms of the sequence defined by this formula, where the formula tells us that to get the value of the general term a sub n, you do the term number, n, squared, plus 1. So let's find the value of the first 3 terms. To find the value of the first term, I'll just replace these n's with 1. So term a sub 1 would equal 1 squared plus 1, which is 2. And then term 2, just replace the n's with 2. It would be 2 squared plus 1, which would be 4 plus 1, which is 5. And then the third term, a sub 3, would be 3 squared plus 1, which is 9 plus 1, which is 10. So the first 3 terms of the sequence are 2, then 5, then 10. Must know number 2, an arithmetic sequence. This is the first of 2 special types of sequences we're going to look at. An arithmetic sequence is a sequence where each term increases or decreases by the same number each time. That number is called the common difference. So if we have a sequence of numbers that go up or down by the same amount each time, we can find the value of the general term, the nth term, which we write as a sub n, by starting at our first term a sub 1, and then adding our common difference, d, n minus 1 times. So add n minus 1 multiplied by d. So once again, in this formula, a sub n is the nth term, a sub 1 is our first term, n is the term number, and d is our common difference, which just means the difference between consecutive terms in the sequence. So let's look at a couple examples of arithmetic sequences. Example 1, I have this sequence of numbers that goes from 4 to 7 to 10 to 13 to 16, and this ellipsis means it continues forever. If I were to look closely at this sequence, looking at any pair of numbers that are right beside each other, the difference between those two numbers, if I do the second number in the pair minus the first number in the pair, the difference is 3. Right? The difference between 7 and 10 is 3, between 10 and 13 is 3, and so on. So in this sequence, to get from one number to the next number, I just have to add 3. Each time, that common difference is 3. That's what makes this an arithmetic sequence. So what I could do is I could write a formula for the general term of this sequence following this template. The value of the general term, term a sub n, would equal the value of the first term, so in this case, 4, plus n minus 1, multiplied by the common difference. Well, the common difference between each pair of terms, we noticed, was 3. So plus n minus 1 times 3. With this formula, I'm able to find the value of any term in my sequence just by subbing in the term number I want the value of for n. So let's look carefully at why this formula works by calculating the value of the third term, which we know should be 10. So to find the value of the third term using my formula for the general term, I'll sub in 3 for n. So a sub 3 would equal 4 plus 3 minus 1 times 3, which is 4 plus 2 times 3. So I need to add this common difference of 3 2 times to my initial value of 4. And that gets me my third term. And 4 plus 2 times 3, that's 4 plus 6, which is 10. But if we look closely at this line right here, 4 plus 2 times 3, what's happening is to get my third term, I start at my first term, 4, and then I add that common difference of 3 2 times. Right? In this sequence of numbers, to get the third term, I started at my first term, 4, and added the common difference 1 time, 2 times. And if I wanted the fourth term, I would add the common difference 3 times. And if I wanted the 10th term, I would add the common difference 9 times, which is why in the formula it says to get the value of any term, you start at the first term, add the common difference n minus 1 times. You add the common difference 1 less than the term number to get the value of the nth term. And let's see how we could use that formula to do example 2. It says how many terms are in this sequence? Well, this sequence, notice, is not an infinite sequence. It's a finite sequence. The sequence starts at 38 and ends at negative 20. But all the terms in this sequence aren't listed. This ellipsis in the middle of the sequence means we skipped a bunch of values. Instead of having to actually rewrite the whole sequence with all those missing values filled in to figure out what term number negative 20 is, we can use our formula for the general term, which looks like this. Right? In this sequence, I can see there is a common difference between each pair of values. In the first pair of values, I notice the common difference is negative 2. In each pair, I always do the second one minus the first one to find the difference. 36 minus 38 is negative 2. So to get from one term to the next in this sequence, I would just have to add negative 2. Or another way of thinking about that is just subtract 2 each time. So you can see the common difference between each pair of values is negative 2. So in my formula for the general term, I could say a sub n would be equal to the first term, which is 38, plus n minus 1 times the common difference of negative 2. That would be the formula for the general term of the sequence. And what I want to do is figure out what term number is negative 20. So I can replace the actual value of the nth term with negative 20, and then solve the equation for n. To isolate n in this equation, I would start by subtracting this 38 to the other side. I would have negative 20 minus 38, which is negative 58. Then I would divide both sides by -2. On the right, the -2's cancel. And on the left, -58 divided by -2 is 29. And then lastly, take this -1, move it to the other side, it becomes +1. So n would be 29 plus 1, which is 30. So because n is 30, that tells me that in my original sequence of numbers, this -20 is the 30th term. Must know number 3, geometric sequences. A geometric sequence is a sequence where each term is found by multiplying the previous term by the same number each time. That number is called the common ratio. And the formula to calculate the value of the nth term, which we call the general term of any geometric sequence where there's a common ratio between consecutive terms, is you do the first term, term a sub 1, multiplied by that common ratio n minus 1 times, where a sub n is the value of the nth term, a sub 1 is the value of the first term, r is the common ratio, and n is the term number. So let's look at a couple different examples of geometric sequences of numbers and how we can use this formula to define the sequences. Starting with example 1, I have this infinite sequence of numbers where to get from one number to the next number, I can just multiply by 3 each time. Or another way of thinking about it, if I look at any pair of numbers in this sequence that are beside each other, within a pair, if I do the second number divided by the first number, so in this case 18 divided by 6, in that pair, I would get 3. And that would be the same ratio you got for any pair of numbers. If you did the second number in the pair divided by the first number in the pair, you would get 3, which is why multiplying any number by 3 gets you to the next number in the sequence. So I could describe the general term of this sequence, the nth term, term a sub n, I could describe it as the first term, a sub 1, which in this question is 2, being multiplied by the common ratio, which we know is 3 for this sequence, n minus 1 times. And now let's look at how this formula works to find the value of, let's say, the third term, which is 18. So how can we use the formula to get that value of 18? Well, if I sub in 3 for these n's, that would allow me to find the value of the third term, which we write as a sub 3. That would be equal to 2 times the common ratio of 3, 3 minus 1 times. Right, to get the third term, I multiply by the common ratio just 2 times. And that's what this formula simplifies to. 2 times 3 squared. The initial value of 2 gets multiplied by the common ratio of 3 2 times. 2 times 3 squared is 2 times 9, which is 18. And we can see that that verifies with what we have in our sequence. The third term is 18. And now in this sequence, I only see the value of the first 4 numbers. What if I wanted the fifth number? Well, I would just have to multiply this 54 by 3. Or I could use my formula for the general term and find term 5 by replacing n with 5. The fifth term, a sub 5, would equal 2 times 3 to the power of 5 minus 1. That's 2 times 3 to the 4, which is 2 times 81, which is 162. So the next term in this sequence is 162. I'll make a bit of room and let's do one more example. Example 2, it says how many terms are in this sequence? Well, in this sequence, I noticed that this is a geometric sequence because there is a common ratio between consecutive pairs of terms. To get from one term to the next, I just multiply by a half. Right? 1280 times a half is 640. 640 times a half is 320. And so on. The pattern holds true. In any pair of numbers, if I picked a pair of numbers that are beside each other, in the pair, if I do the second number divided by the first number, I get that common ratio of a half. 320 divided by 640 is a half. So because there is that common ratio between consecutive terms, it's a geometric sequence, and we can define the general term of that sequence using this formula. Where to find the value of the nth term, I would do the value of the first term, which in this sequence is 1280, and multiply that by the common ratio of a half, n minus 1 times. So if I want to know how many terms are in this sequence, well, it ends at a term that has a value of 5. So replace the value of the nth term with 5, and then rearrange to solve for n. Well, I would start by dividing both sides by 1280. On the right, the 1280s cancel. On the left, it reduces to 1 over 256 equals a half to the power of n minus 1. And now to solve this, I'll have to make a bit more room. And then I'll continue over here, where I'm going to rewrite this 1 over 256 as a power of a half, so it matches the power on the right side of the equation. Well, 2 to the 8 is 256, so I can write this as a half to the power of 8. That's equivalent to 1 over 256, and that should be equal to a half to the n minus 1. And now because we have a power equal to a power, where the bases of those powers are equal, the only way the equation could be true is if the exponents were equal to each other. So 8 would have to be equal to n minus 1. Move the negative 1 to the other side. 8 plus 1 is 9. So I know this 5 is the 9th term in this sequence, which means the sequence has 9 terms. Must know number 4, recursive sequences. A recursive sequence is a sequence where each term is defined in terms of one or more previous terms. So to show you what that looks like, to be able to define a sequence in terms of previous terms in the sequence, let's look at an example. In this example, we want to list the first 4 terms of this recursive sequence. And what makes it a recursive sequence is that to find the value of the general term, the nth term, we need to know the value of the term before the nth term, term n minus 1. That's what makes this a recursive sequence. We need to know the previous term. And also in any recursive function, you'll notice it will give you the value of the first term. We would need that to be able to find the value of any subsequent term. So when listing the first 4 terms, we already know the first term, so I'll rewrite it. And then to find term 2, I would just need to replace these n's with 2. So I would say term 2 is equal to 2 multiplied by term 2 minus 1. And 2 minus 1 is 1. So really what the equation says, it says to find the second term, you do 2 times the first term, which is the term before term 2. It's the previous term. So I would do 2 times term 1, and term 1 is 2. So I would do 2 times 2, which is 4. And then if I want to find the third term, if in this formula for the general term, I replace the n's with 3, I get the third term is equal to 2 multiplied by term 3 minus 1. And 3 minus 1 is 2. So it says to get the value of the third term, I do 2 times the value of the second term. And the value of the second term was 4. So I do 2 times 4, which is 8. And then lastly, we have to find the fourth term. To find the fourth term, I do 2 times the previous term. So 2 times term 3, which would be 2 times 8, right? The previous term was 8. So I get 16. So if I were to write out the terms in this sequence, the sequence goes 2, 4, 8, 16, and so on. Notice this is a geometric sequence. To get from one term to the next, we multiply by 2. But geometric sequences can be written recursively, like we have above. And now let's do another example where I'll give you a sequence of numbers and we'll try and write a recursive function to define that sequence. The example says to write a recursive formula for this sequence. Now this sequence is not arithmetic or geometric, but we can still define it with a recursive formula. In the recursive formula, we always need to start by stating what the first term is. So we can say term number 1 is 2. And then we also have to state how to find the value of any general term, term n, by using the value of the previous term, term n minus 1. Well, to get any individual term in this sequence, what do I do to the previous term? Well, if I zoom in on it here, to get from the first term to the second term, we add 1. To get from the second term to the third term, we add 2. And then to get to the fourth term, we add 3, and you can see how this pattern continues. But how do we work this into a formula? Well, let me list underneath each of those terms what term number they are. Notice the relationship between the term number and what we add to the previous term. If I want the value of the third term, let's say, I add 2 to the previous term. If I want the value of the fourth term, I add 3 to the previous term. If I want the value of the sixth term, I add 5 to the previous term. So what you do is you take the previous term, so the term before term n would be term n minus 1, and then what you do is you add 1 less than whatever term number it is you're finding. So I need to add 1 less than n. And let me show you how this formula works by finding the 7th term in this sequence. If I want to find term 7, the formula would tell me to do the previous term, term 7 minus 1, which means term 6, and then add 7 minus 1. And then to simplify this formula, the 6th term I can see in my sequence is 17. So I would take 17, and then to that I would add 6. 17 plus 6 is going to give me my 7th term of 23. Right, and we could see in our sequence, the next term, I would add 6 to it, and that would give me 23, which would be the 7th term. Must know number 5, a series. A series is the sum of the terms of a sequence. So if we had some general sequence made up of term 1, term 2, term 3, term 4, and so on, if I were to write its corresponding series, that would just be the sum of all of the terms that make up the sequence. So it would be the value of term 1 plus the value of term 2 plus the value of term 3 plus the value of term 4 plus and so on infinitely. So let's do an example so you can get the hang of what a series actually is. The example says to calculate S sub 4, which means the sum of the first 4 terms of the sequence represented by this formula for the general term of the sequence. Well, if I want to find the sum of the first 4 terms of the sequence, I'm going to have to find the value of the first 4 terms using this formula for the general term. So I'll start by finding the value of term 1 by subbing 1 in for n. It would be 1 plus 1 minus 1 times 3. And that would be 1 plus 0 times 3, which is just 1. Then to find term 2, sub in 2 for n, and it would be 1 plus 2 minus 1 times 3, which would be 1 plus 1 times 3, which is 4. And then I'll do the same thing to find the values of both term 3 and term 4. And notice the terms of this sequence form an arithmetic sequence. You may have even noticed that this formula for the general term matches the structure of the general term of an arithmetic sequence, where this 1 is the value of our first term, and this 3 is the common difference between terms, which is why this sequence goes from 1 to 4 to 7 to 10. There's a common difference of 3 between consecutive terms in this sequence. So I could write out this sequence as follows, where it goes from 1 to 4 to 7 to 10. But if I want the sum of the first 4 terms, I'll actually write the series that corresponds to this sequence. And when writing a series, we add up the terms in the sequence, making the series 1 plus 4 plus 7 plus 10 plus and so on. But this question only asks us to find the sum of the first 4 terms, so I don't have to continue this infinitely. I can say the sum of the first 4 terms would just be equal to 1 plus 4 plus 7 plus 10, which is equal to 22. Must know number 6, sigma notation. Sigma notation is a more compact way of writing the sum of the terms in a sequence. In the last section, we learned that if we're adding up the terms in a sequence, that's called a series. And if I wanted the sum of the first n terms in a sequence, I could write it as a series where I just add up the terms that make up that sequence. Add up the first term with the second term with the third term, all the way until I get to the nth term of that sequence. But instead of having to list out the sum of all of those terms in our series, we can instead use a sigma notation which indicates we add up all the terms all the way from the first term to the nth term. And how that sigma notation looks, we would say the sum of n terms is equal to, and then I write a capital sigma, which means the sum of all of the terms, I'll say term a sub I, from term 1 to n. So from when I equals 1, all the way up to when I is equal to n. At the bottom of the sigma is our lower limit for summation, and at the top of our sigma is our upper limit for summation. So this just means the sigma means add up all of the a sub I terms from an I value of 1 all the way up to an I value of n. And that will find us the sum of all of the terms in the sequence from the first term up to the nth term. And to show you how this summation notation works, let's do a really quick example. In this example, it says to find the sum of all the I squared terms from I values of 1 up to 5. So what we have to do is one by one iterate through I values from 1 to 5 into this I squared term and then add them all together. So to find the sum, I'll start with my lower limit of summation by letting I equal 1. So I'll replace the I in I squared with 1, giving me 1 squared. And then plus, and now I move on to the next value between 1 and 5, which would be 2. So I'll change this I in I squared now to 2, making it 2 squared. Plus, and then I keep iterating through the I values until I get all the way up to 5. So I've gone from I values of 1 to 2. The next will be 3, so it'll be 3 squared. Then plus 4 squared, plus 5 squared, and then I stop, because 5 is my upper limit of summation. So I found the value of I squared for I values all the way from 1 to 5. I made the I values 1, 2, 3, 4, and 5. And now adding those together, I'll evaluate all of the squares, giving me 1 plus 4 plus 9 plus 16 plus 25. And that is going to be equal to 55. Must know number 7, an arithmetic series. An arithmetic series is just the sum of the terms of an arithmetic sequence. And an arithmetic sequence, remember, is a sequence where consecutive terms have a common difference. They increase or decrease by the same amount each time. And the value of the general term of an arithmetic sequence is equal to the value of the first term plus the common difference n minus 1 times. So plus n minus 1 times the common difference. This gets you the value of any individual term in the arithmetic sequence. So if I wanted to find the sum of all of the terms that make up an arithmetic sequence, I could use a capital sigma, which means find the sum of all of these terms in the arithmetic sequence, all the way from the first term, so if the n value was 1, up to, let's say, some value k. I'll make my upper limit of summation k. So if I find the sum of all of these terms from an n value of 1 all the way up to k, what I have found is the sum of the first k terms of that arithmetic sequence. Now, instead of having to find the value of all of the terms all the way from term 1 up to term k and then add them together, there's actually a shortcut formula that works for finding the sum of the terms in an arithmetic sequence. And that shortcut formula looks like this. The sum of the first n terms is equal to n divided by 2 of the first term plus the nth term. So if I add the first and last term together and then divide by 2, I've essentially averaged them, and then I multiply by n, which is equal to the number of terms in that sequence. And that's going to find me the sum of the first n terms of that arithmetic sequence. So let's do a couple examples to see how that works. The first example says to find the sum of the first 20 terms in this sequence. Well, the first thing we should notice is that this sequence is an arithmetic sequence. The common difference between each pair of terms is 3. Right? To get from one term to the next, you just add 3 each time, which means there's a common difference of 3, which is why this is an arithmetic sequence. So if I want the sum of the first 20 terms, I don't actually have to list out all 20 terms and add them together. I can instead use this shortcut formula. The shortcut formula, I need to know n, which in this case is 20. We want the sum of the first 20 terms. We also need to know the value of the first term, which I see is 5. But I also need to know the value of the last term, right? If I'm finding the sum of the first 20 terms, I need to know the value of the 20th term. Well, to find that, I can use the formula for the general term of an arithmetic sequence. So to find the value of the 20th term, I take my first term, which is 5, and I add the common difference n minus 1 times. So I'll add 20 minus 1 times the common difference of 3. And that actually equals 62. So now I can go ahead and use this formula for the sum of the first 20 terms. The sum of the first 20 terms would equal 20 over 2 multiplied by the first term, which is 5, plus the last term, which is 62. So this gives me 10 times 67, which is 670. That would be the sum of the first 20 terms that make up this sequence. Must know number 8, a geometric series. A geometric series is the sum of the terms in a geometric sequence. Well, remember the formula for the general term of a geometric sequence would be term n is equal to term 1, so a sub 1, times the common ratio to the power of n minus 1. And if I want to add up all the terms in a geometric sequence, I can use summation notation with a capital sigma, which means find the sum of all of these terms from the first term, where n equals 1, all the way up to, let's say, term k. And that would find us the sum of k terms in that geometric sequence. But instead of having to calculate the value of every single term and then add them all together from term 1 up to term k, we could instead use a shortcut formula. A formula for the sum of n terms in a geometric series is the first term multiplied by 1 minus the common ratio to the power of n divided by 1 minus the common ratio. So to use this formula, we can find the sum of all n terms in the series by just simply knowing the first term and the common ratio between consecutive terms. So let me show you how both of these formulas can work. Let's do an example. The example says to find the sum of the first 7 terms of this sequence. Well, if we look carefully at this sequence, I can tell it's geometric because there's a common ratio between terms. To get from one term to the next term, we just multiply by 2. And since we already have the first 5 terms of the sequence, and we only want the sum of the first 7 terms, it wouldn't be too difficult to use this version of the formula, where we just find the sum of all of the terms in that series. So to find the sum of the 7 terms, it would be the sum from term number 1 up to term number 7 of the first term multiplied by the common ratio, n minus 1 times. And in this sequence, the first term is 3, and the common ratio is 2. And now one at a time, I'll sub the whole numbers between 1 and 7 in for n to get the first 7 terms of the sequence, and then add them all together. Well, the first 5 terms I see right here, so I can rewrite those with addition signs between them. To get the 6th term, if I sub 6 in for this n, I'll get 96. And then my 7th term, if I sub 7 in for this n, I get 192. And then adding all of those terms together, I get 381. So that's one way to get the sum, where we literally just add up all the terms. But remember, there's another formula we can use where we don't have to add up all the terms. Using that formula, the sum of the first 7 terms would be equal to the first term, which is 3, multiplied by 1 minus the common ratio to the power of n. So in this case, 1 minus the common ratio was 2 to the power of n, which is 7, right? I want the sum of the first 7 terms. And that's all over 1 minus the common ratio, so 1 minus 2. 1 minus 2 to the power of 7, that's 1 minus 128, which is negative 127. And now finding the product of 3 and negative 127, and then dividing it by negative 1, I once again get that sum of 381. Must know number 9. Finite versus infinite series. A finite series has a set number of terms. For example, this series is just the sum of those 5 terms. And if I add those 5 terms together, the sum is 30. Whereas an infinite series continues forever. For example, this series, where these 3 dots mean that that series goes on forever. And in fact, the sum of all the terms in this series does not approach a finite value. But some infinite series do. If we look carefully at a geometric series, where we find the sum of k terms in a geometric series by adding up all the terms from term number 1 up to term number k, where each term we can get by doing the first term multiplied by the common ratio to the power of n minus 1, right? Geometric series have a common ratio between consecutive terms. If that common ratio has an absolute value that's less than 1, it's actually going to be a convergent infinite series. Which means even though it's an infinite series, even though we're adding up an infinite number of terms, the sum does approach a finite sum. So if we look at this example of a geometric series, notice the common ratio between consecutive terms in this series is a half. If you multiply it by a half, you can get from one term to the next term, and that ratio stays constant. And because that ratio of a half has an absolute value less than 1, we know that this series, even though it is infinite, it's going to converge to a finite sum. And we can calculate that finite sum for an infinite geometric series by using this formula. We can find the sum of an infinite number of terms in this series by doing the first term divided by 1 minus the common ratio. So in this case, first term is 1, and our common ratio is a half, so divide it by 1 minus a half. And 1 minus a half is a half, so we have 1 over a half, which is 2. So if we were to start at 1 and keep adding terms that keep getting cut in half, the sum of all those terms is going to approach 2. But if the common ratio between terms has an absolute value that's bigger than 1, we actually call it a divergent infinite series, which means the series does not approach a finite sum. So for example, let's look at this series. To get from one term to the next in this series, we multiply it by 2. So the common ratio between terms, in this case, is bigger than 1, which means this sum does not approach a finite value. So if you have an infinite geometric series, basically, if the terms are getting smaller, then the sum is going to converge to a finite value. But if the terms are getting bigger, then the sum does not approach a finite value. Must know number 10, special sequences. I want to show you 3 special types of sequences. The first one are the square numbers. If you were to just square the term number to get the term value, the sequence would start with 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, and so on. So the formula to get the general term of this sequence, to find the nth term, you would just do that term number squared. The next special sequence I want to show you are the triangular numbers. The first 4 triangular numbers are 1, 3, 6, 10, and so on. We call these triangular numbers because we can make equilateral triangles using dots with these corresponding amounts. So here's what they would look like with 1 dot, or with 3, or with 6, or with 10. So hopefully you can see how all of these form equilateral triangles. And to generate the next triangle in this sequence, I just have to add one more row at the bottom, which is going to have one more dot than the previous row had. So I would have to add a row of 5 dots to get the next number, making the next number in the sequence 15. And then I would have to add 6 to make the next number 21, and so on. And to describe this sequence with a formula, we could do it recursively pretty easily. To get the nth term, we just take the previous term and add n. To get the second term, we added 2 to the previous term. To get the third term, we added 3 to the previous term, and so on. Or instead of recursively, you can find the value of the nth triangular number by doing n times n plus 1 divided by 2. And then the last, possibly most famous sequence of numbers I want to talk about are the Fibonacci numbers. The Fibonacci sequence starts with 1, 1, 2, 3, 5, 8, 13, and so on. And notice any one term in this sequence, so for example 8, is the sum of the two previous terms. So we could write the formula for the general term recursively. To get the nth term, you just add the two previous terms, term n minus 1 and term n minus 2. So to get the term after 13 in this sequence, I would add the two previous terms. I would add 8 and 13 together to get 21. And there are tons of amazing patterns in the Fibonacci sequence, but I'll save that for another video. So if you made it to the end of this video, hopefully you have a great understanding of sequences and series. Let me know in the comments what you want a top 10 of next.
Jensen Man.